In this video, I'm going to continue with my previous video about solving systems of equations using elimination. Now, in part one, I covered some very simple examples of solving systems using elimination. And if you didn't watch that video, you need to go back and watch it. It's labeled part one in order to make sense of what I'm about to do. Now, if you remember, to solve a system of equation using elimination, really the first thing to check and see is if both equations given are in standard form. If one equation is written in slope-intercept form, or it's very easy to isolate a variable, you most likely want to use substitution. In this case, both of my equations are in standard form, so I'm going to use elimination to solve it. Now, step one is to pick a variable to eliminate. Now, in the previous video, it was really easy to pick a variable to eliminate because one had a positive coefficient while one had a negative. In this problem, it's a little bit more difficult because here I have a 1, a 2, and a 4, a 1. So it really doesn't matter what we pick. So what I'm going to do is I'm going to eliminate x because I can. So in order to eliminate x, I need to turn this 1x into a negative 2x. Now the reason, again, I want to make this negative 2 is because I'm going to add my equations, and 2 plus negative 2 is 0. So what I'm going to do is I'm going to multiply the entire top equation by negative 2. So here's what I get. Multiply every part by negative 2, which is perfectly fine since I do it to both sides. I get negative 2x minus 8y equals negative 24. And I'm going to go ahead and rewrite the right equation. Now, since I have multiplied the entire top equation by negative 2, I now have a negative 2x and a positive 2x. So now I'm going to go on to step 3, which is add the equations. Now, if you remember, the fancy term for this is linear combination. So I'm going to add negative 2x and 2x. That gives me 0x. Negative 8y plus 1y is negative 7y. And negative 24 plus 10 is negative 14. Now again, I don't need to write the negative 0 or the 0x, so I'm just going to write down negative 7y equals negative 14, divide by negative 7, and I get a y value of 2. Now, just like in every other system, I need to have the x coordinate to go with this y. So I'm going to choose an equation and replace the y with 2. I'm going to go ahead and choose the second one, the red one. So 2x plus 2 equals 10. So I'm just replacing the y with 2. And I'm going to solve for x. So that equals 10, subtract 2, so 2x equals 8, divide, and x equals 4. So this gives me the solution for 2. So let's take a look at a more complicated example. So here I have 3x plus 4y equals 12, and 2x plus 5y equals 8. Now again, both of these are in standard form, so that tells me right off the bat that I'm going to use elimination. Now the first step is choosing a variable to eliminate. Now in all the examples I've shown you so far, it's been pretty easy to see which one I'm going to eliminate. But here, it's a little bit tougher. Here I've got a 3 as a coefficient and a 2 as a coefficient. It's not very easy to multiply 3 to get 2. And here I've got a 4 and a 5. It's not very easy to multiply a 4 to get 5 without having funny decimals. So what I'm going to have to do is I'm going to have to multiply both equations. Now, really, it doesn't matter which variable to pick. I'm going to choose to eliminate y. Now, I'm going to do a little thought process for you to help you determine what you're going to multiply each equation by. So here's what I know. I know that 4 times 5 equals 20. I'm just doing straight multiplication, 4 times 5. So what I'm going to do is I'm going to turn the top into a negative 20, and I'm going to turn the bottom into a positive 20. Now I could flip this. I can make this negative and this positive. So long as they're opposite, it doesn't matter. So using that logic, I'm going to multiply the top equation by negative 5. because when I do positive 4 times negative 5, it gives me negative 20. And for the bottom, I'm going to go ahead and multiply by 4, because that'll give me a positive times a positive. It stays positive. So let's go ahead and multiply this out. So the whole top, I multiply everything by negative 5. So that would be negative 15x minus 20y equals negative 60. And the bottom, I'm going to multiply everything by 4. So I get 8x plus 20y equals 32. Now I see here I have a negative 20 and a positive 20. That's great. Now I can go ahead and do linear combination. So let's go ahead and add negative 15 plus 8. That's negative 7x. This is 0. Negative 20 plus 20 equals negative 28. Now again, I don't need to include that 0. It's unnecessary. So I have negative 7x equals negative 28. I go ahead and divide both sides by negative 7, and I get x equals 4. So there's my x value. I need to find the y to go with it. Now here's the thing. I can choose to use the green equation, the purple equation, the red equation, or the blue equation to find my y. It doesn't matter. I'm going to choose to use the blue one just because why not? Plus 4y equals 12. And what I'm going to do is I'm going to replace x with 4. So 3 times 4 plus 4y equals 12. So let's see. I get 12 plus 4y equals 12. Subtract from both sides. So I get 4y equals 0. That's perfectly fine. I can have 0. Divide both sides by 4. And I get y equals 0. So my solution here is the point 4, 0. And that is just a brief tutorial on how to do a little bit more advanced systems of linear equations using elimination.